Hi, everybody. I wanted to get together with you this evening and talk a little bit about the test review for chapters 9 and 10. You've got a test coming up on Monday. I hope everybody has thawed out from our snow days, or actually I guess it was ice days, and I'm assuming everybody's getting ready for the Super Bowl tomorrow. So I know we are, and before I head on in and make my chili, I thought we'd go ahead and just talk a little bit about the review. It's out on the Blackboard site under this week's lessons, and you have all of the problems worked out. But I do want to talk about why you would want to use a particular test, because this review is a mixing up of all of the various things that we've been talking about in chapters 9 and 10. And if you take a look at problem number 1, the first thing that you need to do is to figure out what kind of a test is it that we're doing. Are we doing an F test, a chi-square test, or a Z test? Because those are the three possibilities. Now, in number 1, it says, a retail manager in Seattle believes that the standard deviation of a number of people calling in sick each day is greater than 8. So, in problem number 1, it says the standard deviation is greater than 8. Now, we have one standard deviation, and we're testing it against a particular number. And when that happens, we want to use chi-square. And remember, with chi-square, you have to set it up so that it's variance that's being tested in your hypotheses, not standard deviation. So that's why whenever you have your hypotheses, our null and our alternative hypotheses are in terms of standard deviation, and it's going to be less than or equal to or greater than or equal to 64 because we've squared both sides of this claim. Now, as you go through and you do the problem, you identify what your chi-square critical value is. You set up the regions where the null is going to be okay, where you're going to reject. And in this particular case, remember with chi-square, the critical value is based on degrees of freedom, and our degrees of freedom here is going to be 34. Since that isn't in the book, I don't believe, you're going to have to go back and you're going to have to use a degrees of freedom 30. So your critical value will end up being 40.25. And your calculated chi-square, which is given by n minus 1, s squared over sigma squared. Whenever you put those numbers in, you get 34. Your s squared, according to the chart that you're looking at, is going to be the 125.49. And then over your 64. And when you calculate that, it becomes approximately 66. Okay? Well, that's way out here. So you're going to reject the null, and you're going to make some sort of a statement about your claim. So that's problem number 1. Now, if with problem number 2, we're using some of the same data, but it's a different problem. On problem number 2, it says the same manager has another store in Chicago and thinks that there's a real absentee problem. In a sample of 32 days, he found on average 22.64 people call in sick. Gives the standard deviation, and then it says the manager thinks the Chicago store has more absentees than the Seattle store. So in number 2, what we're talking about is, with absentees, we're not talking about standard deviation anymore. We're talking about mean. And he's thinking that the mean of the Chicago store is greater than the mean of the Seattle store. So when we're talking about two different means, what is your test? Your test is going to end up being a Z. And it's the Z where you have the difference of two means. And you can see on your workout that's out on Blackboard that we come up with our Z value, we come up with our calculated value, and we go through and we come up with our answer comparing the averages. So if you have questions on that one, email me about it. But I think the calculations are pretty straightforward. I just want you to understand what it is that you're testing. Now with number 3, we keep on this same Chicago and Seattle thing, and it says, for a complete analysis of the 2 stores from problems 1 and 2, the HR specialist wants to verify the variance in the attendance data is different. So now what we're talking about is variance equal and variance not equal. And with that, here's our null, here's our alternative. Difference of 2 variances, we're talking about an F test. And you can see the workout of that on Blackboard as well. But I just want you to realize the difference between the verbiage on these particular problems. With number 4, well, that one again has to do with the difference in Indiana and the difference in North Carolina. So it's means. What kind of a test is that? Yep, you got it. Again, that's a Z test. And then finally, for number 5, it talks about the variances in height for the various leagues. 2 different variances. You're talking about an F test. So, the reason I wanted to get together with you was so that you would understand how the problems are going to be worded and what to look for whenever you're trying to decide, is it a chi-square, is it an F, or is it a Z? Z has 2 means, F has 2 variances, and chi-square has 1 variance with 1 value that it's testing. If you have any questions, send me an email. I'm not going to be answering during the Super Bowl, but I will answer before and after, and I hope you have a great rest of the weekend. Talk to you later.